So in this video I am going to discuss about the frequency divider circuits. So how you are going to design our frequency divider circuits by using it's like using counters only. So how you are going to design the frequency divider circuits using the counter. Before that, we have to know about what is the frequency divider circuits like that. So this is the definition of the frequency divider circuit. So a frequency divider is an electronic circuit that takes a period of input signal. So it takes some input signal, means it takes some clock like that, and provide the output whose frequency is the fraction of the input. So while you are discussing the frequency divider circuits, then you understand properly. Until now we can simply know the definition. So whatever the output, it is the fraction of the input. So you also get waveform only, but it is the fraction of the output. So you will get like this something, the fraction of the input you are get as a output, typically represented by the formula. It will get the formula like F out is equal to F. What you can say from this means, if you can if the n value is equal to 2, then F by 2 circuit will get. If n value is equal to 3, then you get F by 3 circuit. So means frequency divided by 2, frequency divided by 3, like that you are going to get the frequency divider circuits. So for that, this is the F by 2 circuit, frequency divided by 2 circuit. So for that we are going to use the mod 2 counter. So this is the circuit of our mod 2 counter. So what you are going to do? So see here, what will count here in mod 2, it will count 0 and 1 only. So means, see, this is the circuit. The input frequency is our clock frequency you are going to give, and whatever the output of the D flip flop we are going to get, it is our directly F by 2 circuit. It is a very simple circuit. So this is our clock. What is going to be done for every pause edge of clock? So we are going to give pauses. So for every pause edge of clock, you are going to get our output. So see, first the output is going to be 1, and then again our output is going to be 0, and again you are going to get it as 1. So see here, this is the one clock cycle, this is the another clock cycle. So this is the another clock cycle. First, what you are here, you can observe, for completing the complete cycle, here we are how many clock cycles you are going to get? So 1 and then 2, then only your complete output clock cycle is going to be complete. So that because of that you can say it as a F by 2 circuit, means for 2 clock cycles you are going to get our complete output cycle. So that's why I call it as a F by 2 circuit. So next, it is our it is our F by 4 circuit. So for F by 4 circuit we need two flip flops, and we are going to consider the mod 4 counter. So mod 4 counter, what it is going to be count? So 0 0 0 1 1 0 1 1. So what is our frequency 4 by 2 circuit? Means your output is 2 cycles for 0, and again 2 cycles are 1. So here you can observe 0 0 1 1. So we can consider our MSB bit. So if you consider our MSB bit as your answer, then you simply get the F by 4 circuit. You can understand by waveform, it is very clear to you. So first you can observe that this is the first mod 2 counter. So then what you are going to do, you can give the output of the first flip flop to the clock of the another input. It seems like the asynchronous clock. So you are going to give the output to be the input of the second flip flop clock. So like that we are going to understand by using this waveform. So just see. So this is our clock. For every pause edge of clock, it is going to be means it is going to be change the output. So here the pause edge. So then again it will be. So it is our, seems like it is our F by 2 circuit. QA will be. For what you are getting, so F by 4 circuit, you are going to consider the MSB bit. So this is our MSB bit. So see here. So it is our pause edge of clock. So why I consider this means, so see here the clock is our output of the first one. So according to the output we are going to consider this one. So this is the another one, like that. Here the pause edge, it will be 1, and again pause edge, it will be 0 and 1 0, like that. So here this is the one clock cycle, this is the another clock cycle. So for every clock cycle means one high one low. So this will be considered as one complete cycle. You all know about this. So this is the another clock cycle. So this is the another clock cycle. So here observe, for completing one complete cycle of the output. So here one complete half cycle is going to how many clock cycles it did cover? So it cover the 4 clock cycles. So 4 clock cycles is our input. So for 4 clock cycles of input, we get the single clock cycle at output. So it is our f by 4. So how many clock cycles it will be covered? So it will be say as that circuit. So it will be the f by 4 circuit. So this is our f by 8 circuit. So for f by 8 circuit, you are going to get the 3. You are using 3 flip flops. So for 3 flip flops, what is the combinations? You are getting 8 combinations: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So here again observe the MSB bit. So for 4 clock cycles it will be 0 and 4 clock cycle it will be 1. So means total 8 clock cycles. For if you give 8 input clock cycles, 4 will be the 0 and 4 will be the 1 for the final output. Then it will be say as the f by 8 circuit. So when you are going to observe the waveform, you can clearly understand. Before knowing this, you have to know what is the clock counter circuit, how it is work. So if you don't know about the counters also, you can comment on it. I make a separate video. Okay. Why I go to frequency divider circuits without discussing the counters means someone asked me about these frequency divider circuits using counters. That's why I directly move on to these circuits. So if you don't know about counters while you are watching this, so you can comment on it. I make counter circuit videos also. So next, what is going to happen means, here we need 3 flip flops. So it will be same. So again the output is first flip flop output is going to be input to the second clock, and second flip flop output is going to be input to the third clock. So it is our waveform. So it is our pause edge of clock. So it is our pause edge of clock. So first, what is the first Q is going to be changed for every pause edge of the clock. So it will be changed for every pause edge of the clock. So next, the second flip flop output is going to be depend on the first flip flop output. So that's why it will be toggle whenever it flip flops is pause edge. So second flip flop is going to be toggle for every pause edge of the output of the first flip flop. So it will be changed here only. So see, observe. So pause edge it will be changed here like that. So next, so third flip flop output. So what is our final required output is completely depend on the clock of the second flip flop. Means second flip flop output. So it is our second flip flop output. So it is our pause edge. So you can observe here. So this is our pause edge. Whenever it move from 0 to 1, so it is our pause edge. So if you observe there, it will be changed like this. So see, for complete cycle it is the output. So 1 minute. So this is the complete cycle. This is the complete cycle. When you are saying complete cycle means when you complete the one complete cycle means one act to low and act to high, means logic 0 and logic 1, then you can say it as a complete cycle. So this is our complete cycle. Here you can observe this is the complete cycle up to here. So this is all up to here. Once I erase all, so then you can understand easily. So this is our final one. Here you can observe. So let's count how many clock cycles it need to complete the half cycle for output. So 2 and 3, 4, 5, 6, 7, 8. Here you can observe 8 clock cycles is going to be take to get the output as one complete cycle. So that's why you can say it as a f by 8 circuit. Like that you are going to divide the frequency divider circuits by using these counters. So counters means it is a simple like this. So in counters we are getting output from every pin. But whereas frequency divider circuits you are only get the output from MSB only. So that's why you have to know about the counters while you are understanding these using counters. So I think it's fine. What are the dividers circuits you are going to discuss? There are the so many circuits, f by 3, f by 1.5, f by 7, f by 5. So are the so many. This is the basic steps. So if you want more frequency divider circuits, if you have any doubts in any frequency divider circuits, you can simply comment on it. I make a separate and videos for that. So don't hesitate to ask anything. So thanks for watching. Until then, bye.